How's it going, everyone? Today we are going to be working on Project Euler problem 5 solution. So getting right into the prompt, it states that 2,520 is the smallest number that can be divided by each of the numbers from 1 through 10 without any remainder. And it's asking us to find the smallest positive number that is evenly divisible by all numbers from 1 through 20. So I found the answer online. Yeah, it's right there. Just make sure that we get the right answer. So looking at this prompt, there's a couple things we can tell we're going to have to do right off the bat. We're going to have to loop through some numbers until we find the first one, because once we find the answer, it will be the smallest positive number if we're just looping through a range of numbers. And secondly, since it's saying it's divided by each number 1 through 20 without any remainder, we know we can use remainder division, and we'll have to check basically if the number is divisible in range 1 through 20, and we'll use the mod operator for this, and this will be inside of this function. So because of that, I'm going to start off with the checking divisible first. So I'm just going to go ahead and create a function for that, and we'll just call it is divisible. And we'll pass a variable n just for number through it. So how we're going to start off first is just for I in range 1 through 20, including. And actually, since this is such a large number, just one thing we can do to speed up a little bit is start at 2, because we know any number is going to be divisible by 1. And running through the for loop, we're just going to check if a number isn't divisible in this range, we'll return false right away. That way we don't have to go through the entire thing. So doing that, we'll just do if n mod I doesn't equal 0, that means it doesn't go into it evenly, then we'll just return false. And if it gets through this entire loop, then we know it's gone into every number in that range evenly, so we can just return true. So that's it for this function. It's taking some unnecessary steps. If we need to optimize this more, we can do so at the end, depending on how long it takes to reach this number. That'll be more important in the next function though. So for the next function, I'll just call it find number. This is where we're going to be looping through. You don't have to pass anything through it, or at least I'm not going to. And we're going to have a number to loop things through, so I'll just call it number, or num. And we know instead of starting off at 1 or 0, since 2,520 is the smallest number for 1 through 10, we know it's not going to be any lower than that. So starting at 2,520 will save us that many iterations through this. And since this is divisible is a Boolean statement, or a Boolean function, I'm going to create a Boolean variable, and we'll use it in a while loop. So I'll just call it found, and I'll set it to false right now. And then inside the loop, we can do while found equals false. Now, right off the bat, we are going to have to iterate our number. I'll talk about this a little bit later. And instead of iterating by 1, just knowing it has to go through all numbers from 1 through 20, I'm just going to iterate this by 2 every time, because odd numbers aren't really going to help our case. So that'll save like half of the amount of steps it has to take. And then we can just check found by doing found equals is divisible, and then pass our number through. Now, if found equals true, that means that this number is divisible by everything in this range, and we will exit the loop. So going outside the loop, the only thing we're going to have to do is return num. So I'll move this up a little bit. And then now we just get into writing the script for it. So I'll just call it number equals find num, and then we'll just print the answer out. So we'll just print number. Now, since the answer looks like it's a very large number, I'm expecting this to take a while, as with many Project Euler problems, you have to kind of optimize your code a little bit. So there's a couple things we can do, but we'll just check this first case and see how long it'll take. So I'll go ahead and run this. Oh, excuse me. Okay, so it's looking like it's going to take a little bit. So we'll go ahead and make this look a little bit faster. So right off the bat, one thing we can do, we kind of tackled this problem a little bit with right here, starting off at 2, but we can actually do better than that. So I'm just going to kind of write a new function above this, and then I'll end up deleting that. So we're going to use a list instead, just a list of numbers. And if you want to think about it, if a number is divisible by 20, it's going to be divisible by 2 as well, 5 as well. So you can start to take out some of the factors that are included in it. So a lot of the smaller numbers we're going to be able to take out and just keep the larger numbers of the products of those numbers and then the prime numbers. So we're going to be able to take out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to have to keep 11, take out 12, 15, because 3 and 5, 6 and 2, and so on. So I think that's going to be it, because everything else is... Yeah, so let me just fill in the list without those. So we're going to be looking at 11, 13, 14, and then I'll just do 16, 17, 18, 19, and 20. And just reiterating on this, you want to keep the larger of the products, but the smaller things that make these, you can take out. If that makes sense. It works. Now you don't want to take the larger numbers out and keep the smaller ones. It doesn't work like that. Like you want to keep the largest ones, because if it's divisible by the largest ones, it'll be divisible by the products that make those numbers up. So instead, now we've just went from 18 things we're going through to about 8. So that'll speed that up a little bit. So then we're just going to go through this list. So we'll do for num and checklist, and it'll kind of be the same thing. So we'll do if n remainder division num doesn't equal 0, we'll return false. And if it gets through that entire list, then we can return true. So now we can scrap this part of the function, and we can check to see if this code will run any faster. I'm gonna let it run for a second. So it looks like it's still gonna take a while. The main reason why this is taking so long is because of this. If you think about it, since this is the answer right here, we are starting at 2,520, and we're only going up by 2 every time to get to this number. That's the majority of the time taken in this program. So one thing that works out is I'll write it up here. If 2,520 is divisible from 1 through 10, and we're looking for numbers 1 through 20, we can conclude that whatever the number is that's returned from this will be a multiple of it, or a least common multiple of it. And because of that, in theory, we should be able to iterate by that number. So instead of moving up by 2 steps, I'm going to move up by 2,520 steps. And then we'll run this program again. And actually, just to see how long this is going to take, I'm just going to go ahead and import time. And then I'll do start equals time.time. For anyone wondering how to time a Python program or your operations, this is what you do. Then you create an end instance of that time. And then under this, we'll just print out end minus start. Make sure you do end minus start, or else you're gonna get some weird things. So this is now our code. We went from going through 2 through 18 to iterating through only the numbers we need to and excluding the factors that create these numbers. So we're just left with the higher numbers and primes. And then we also realized that this will have to be a least common multiple of this number. So we can iterate by that instead of going up by 1 or 2 or whatever other unit every step. So now running the code. We'll see if this speeds it up a little bit. And as you can see, we got our answer very fast. And just to put it side by side, because it's a large number, it's hard. As you can see, that is the correct number. And just to show you guys what I was talking about, at the bottom of this, or actually I don't even have to do that. I'll just go into my terminal real quick, type in Python, and I'll print this number, remainder division 2,520. As you can see, it goes into it equally, and I'll also print out that number divided by 2,520. See, so we went from originally, if you would step up by 1, going through that many iterations, to only going through 92,000. So it is a way to speed it up. There's probably a way to speed it up more, but this is my solution. This is how long it took. If you guys have any questions, feel free to leave them in the comments. Thanks for watching.